Welcome back to Crypto University. You have requested the video about upgradable smart contracts, and here it is. We will show you everything that you need to know about upgradable contracts, from building them to deploying them using Hardhat and OpenZeppelin contracts. So let's go into the tutorial. Before we go into the code, let's start with some theory about upgradable contracts. You can see here in this image we have a normal smart contracts. This is how it normally works without upgradable contract. And we have some storage variable. Let's say we have an address, the owner of the contract, and we have a function, a view function, which just returns the owner. And how it works, we have an externally owned account or another contract, and they directly call the smart contract and, for example, call this function and receive the owner address. The contract before was not upgradable because we could just call the function and we could not just exchange the functionality of the contract itself. So how can we implement an upgradable contract on the blockchain? There are different ways to do that, and in this video we will go to see the transparent upgradable proxy pattern, which is one of the most common patterns for upgradable contracts. You can see here such a pattern, and what we actually have is we have our implementation contracts here behind. So here are all the functions defined, and we have a transparent upgradable proxy in the middle, which gets all the calls from the externally owned accounts or from other contracts. So they call the transparent upgradable proxy. And what is important now, all the storage variables are stored within this proxy. And what the proxy does is it makes a delegate call to an implementation contract. So let's say we have first this version 1 contract of my contract. It is deployed at an address. And when now the externally owned account calls the owner function, he passes it to the transparent proxy. The proxy does a delegate call to this contract. That means he executes this function, but on behalf of his storage. So he has the storage of the owner. The owner is set here, but then he executes this function and he just returns the owner to the caller here. And then what we can do now is we can upgrade this functionality here, which means we are deploying a new contract, let's say a version 2 contract of that. And we are adding a new function which can do a change owner functionality, which takes the message sender and sets it to the owner. So what we can do now is we can say to the proxy, we can say, remove this contract as implementation and add this contract as the new implementation, which means we are upgrading the contract. And then the externally owned account here, he can call the change owner function to the proxy. The proxy forwards it here to the version 2 contract and takes this function and executes this function as it's a delegate call on behalf of his storage. So he has the owner variable, and if the EOA calls this function, the message sender, which is the EOA, will be set to the owner address on the transparent upgradable proxy. So the important thing that you need to remember is that the storage is all here on the proxy, and that the implementation contracts will be newly deployed and so on, and they are added to the transparent proxy, which is which implementation that we would like to have to execute the functionality. There is one more important thing to consider. The point is that the transparent proxy itself, here in the middle, has itself some storage and some functions that he needs to have. For example, we need a function, normally it's called upgrade and call, which is used to actually upgrade the contract itself, to set a new address which needs to be used for the implementation itself. So what can happen now is that this upgrade and call function, they could be implemented here, but also on the implementation contracts. And then we have a problem. Then we don't know if the function should be executed on the transparent proxy or if the function in the implementation contract should be executed. And with OpenZeppelin contracts, they have solved that in this way, such that they say, look, each externally owned account, or each address, even other contracts, everything that calls the contract will be delegated to other contracts. However, there is one exception. There is one address which is called the proxy admin, which will be always or never forwarded to the implementation contracts, which will always execute functions directly on the transparent proxy. And this one is also a contract. So this is the proxy admin contract. And then we have an admin itself, which calls the proxy admin, and the proxy admin calls the transparent upgradable proxy. So what they are doing is actually they are upgrading the implementation of the contract. So this is the admin which is allowed to upgrade the contract. You might ask yourself now, why do we need to have this proxy admin here? Why can't we just call from this admin directly to transparent proxy? That's a really good question. It is actually possible to do that, but the reason that we have a contract here in between is that it can be that this admin contract or this address here also needs to be able to execute functions on the implementation. So maybe this admin here is also an admin on the implementation of the contract. So if we do this way direct, it will not be possible for this admin to directly call these functions on the implementation itself. But using the proxy admin, it's possible now that the admin can call the proxy admin, which will be for upgrading the contracts itself, but he can also call directly the transparent proxy to call all the implementation functions behind. So that was it for the theory about upgradable contracts. Let's go into the code now and let's start to implement those contracts and deploy them using all these different contracts. So welcome back with Visual Studio Code and a blank new project. I'm going to set up a Hardhat project now. I will go through that a little bit more fast. If you don't understand some steps, that's absolutely no problem. There is another video that I have created for you, which will go through each step in detail to set up such a Hardhat project. So I'm starting with a new terminal. I'm creating a new folder and let's call it Upgradeable Contract Tutorial. And we go inside this folder. So now let's initialize an npm project with npm init -y. We can see that a new package JSON is created. And now we can install Hardhat. Npm install -save dev to save the dependency of Hardhat. So let's wait a second. It's now installing the Hardhat framework and that's done. Let's clear that again and we can say now npx Hardhat init. And we initialize a Hardhat project. We would like to have a TypeScript project. We can just accept that and yes, and it installs everything that we need to have a Hardhat project on hand. So our Hardhat project is initialized, and now to use OpenZeppelin contracts, so this transparent proxy that we have seen or this proxy admin that we have seen, all these contracts are already implemented by OpenZeppelin and we just want to use these contracts. So what we can do is we can install the upgradable contracts from OpenZeppelin. I will put into description the link for these OpenZeppelin contracts where you can read the documentation about them and you can see much more details about these upgradable contracts. So we say npm install or npm e -save dev, and this is called at OpenZeppelin contracts upgradable, and this should install all our dependencies for upgradable contracts. So when we go here to the package.json, we can see that they were installed here. And when we go inside the node modules, we can go to OpenZeppelin and we can see there are contracts and contracts upgradable. Let's go inside contracts and inside proxy. And we can see that we have here transparent, and here are the transparent upgradable proxy, which we have seen in the theory, and the proxy admin as well. So let's go now to our contracts folder, and we have here a log contract, which is able to log some ether for an owner of the contract, and this is released after some time. He can call withdraw and release the funds. And this contract is not upgradable yet. And what we would like to do now is we would like to make this contract upgradable. What we need to do in this contract to make it upgradable is one thing that is wrong for now. So you can see there is a constructor here, and in upgradable contracts, it's not allowed to have a constructor. The problem is that the constructor is executed when this implementation contract is deployed. And what it does is it sets some fields or some storage variables to some amount. So for example, the unlock time, it sets to the unlock time that you enter in the constructor, or the owner, it sets to the message sender. But we don't want to set these storage variables directly on the implementation contract. We want to set them on the proxy contract, right? But what we saw before, we want to have them on our transparent upgradable proxy. So what we need to do is we need to replace this constructor to a function which then can be called by the proxy contract itself. So when we deploy the log contract, after that, we would like to call a function which behaves like the constructor itself, but sets the storage actually on the proxy, the transparent upgradable proxy. To do that, we need to change this constructor to a function, and we call it initialize. And let's see, no visibility defined, so we need to make that public. And now everything is fine. However, there is one really important thing missing. You can imagine that this initialize function, you can just now call how often you would like to call it. It's not really blocked. So what we need to restrict this function that it can just be called in the beginning and then never be called anymore, that it behaves the same as the constructor itself. So for that, we can import a contract from OpenZeppelin, which is called initializable. So we import from OpenZeppelin / and we get already some help, contracts upgradable, and then I think it's proxy utils and then initializable. Exactly. So now we import this contract and we can extend our contract with that is initializable. And when we have that, we can use the modifier initializer on our function. And that's it. Now the initialize function can only be called once on the deploy time. So our contract now is ready to be upgradable. Let's see if that all compiles. We say npx hardhat compile to see if our contract successfully compiles, and that works fine. So now you have seen that we have compiled two Solidity files, and that's first our log contract, and the second is the initializable contract, which is a dependency of this one. What we want now is we would like to also compile the transparent upgradable proxy contract and the proxy admin contract, which we need for deployment after. So what we do is we make a new Solidity file and we call it proxy.sol. And the only thing that we do here, we just take this license identifier, the Solidity version, and the only thing that we do here is we are importing these OpenZeppelin contracts such that we have them in scope, that we have them in Hardhat, that we can compile them as well. So first we have the OpenZeppelin /contracts/proxy / transparent, and then we have here the transparent upgradable proxy, and we also have the, let's see, I think that should be the proxy admin.sol. Let's see if we can find that. Yes, that works. And we save that file. So this is just importing all these contracts and their subcontracts. And when we call now Hardhat compile, we can see that now we have 13 Solidity files successfully compiled. Of course, that's the transparent upgradable proxy, the proxy admin, and all their subcontracts as well. Now we are finally ready to write our Ignition deployment scripts from Hardhat to deploy our implementation, but also the transparent upgradable proxies and the proxy admin. So what we are doing, we go to Ignition and modules. We have here this log.ts file, which is an Ignition module, which we can use for our upgradable contracts. You see what it does is it just deploys the log contract with some parameter and some value, and that's it. That's actually the functionality that it does. So what we are going to do now, we are rename that and we call it proxy. So this will be our new module, which we will use to deploy all the different contracts that we need. We call it a proxy module and build module. Proxy module is the name of it. We need these parameters. We need still the deployment itself. We delete for now, and we export here the proxy module. So let's think what we need to do first. First, I would say we can start to deploy a new log contract, a new implementation contract, a clean contract, and then we can move on to the proxy contract. So let's say const log, we deploy a log contract with m.contract, and we use the name of the contract called log. We don't need to add any constructor parameter anymore because we have deleted the constructor and we have just the initialize function now. So that's already fine. We just deploy one of these implementation contract. Next, we are going to deploy an upgradable transparent proxy. So we say const proxy, and we say again m.contract to deploy a contract, and we take now the name of this. This is transparent upgradable proxy. That's the name of, let's go here again. That's the name of this contract that we have imported from OpenZeppelin. And what we do, we need to call it with 3 different parameters. The first is the address of the implementation contract. So that's log. Then the second is an admin. So an admin address that we would like to use, which is able to call the proxy admin. This is what we have seen before. Like this is the admin that can actually upgrade the smart contracts or the implementation contracts on the proxy. So we need an account. Let's see. Let's take one. So we say const proxy admin owner. Let's call it like that. And we say m.get account. And we just take the first account that Hardhat provides us. So this is the first account from Hardhat. And we take this admin and we say, this is our admin that we would like to have for our transparent upgradable proxy. And the third parameter is like an initialize call that we would like to do. And we just pass on an empty byte. So really good. We have now deployed a transparent upgradable proxy. What we need to do next is we need to call the initialize function. As we have said before, this needs to be called right after the deployment of the contracts. So let's do that. And the first that we can do is, now it comes something really interesting. We get a new contract. So we say m.contract@. So we load a contract that is already deployed. We load the log contract. This is our implementation contract, but we load it with the proxy address. So what we are now doing is we are loading, like we say, the proxy is actually our log contract. That's exactly what a transparent proxy does. It's like mirroring the implementation itself. So we can say the proxy address is the log contract. We don't really know what is behind the proxy, right? We just see the proxy and we imagine it as being the log contract. So that's what we are doing now. And what we need to do here, we need to also get an ID. That doesn't really matter how we call it, but we need to change this ID because otherwise we have a problem, because we have here a log contract and here a log contract, and Hardhat Ignition gets like confused. So we need to give it a unique identifier. So we call it log proxy instance. And like that, we can load the proxy, but from the view of a log contract. And what we can do now, we can say m.call. We make now a normal transaction to the log proxy. And we say we want to call the initialize function. We want to call the initialize function with a parameter unlock time. So when we go again to the log.sol, we can see that the initialize function needs to have one parameter, the unlock time. And also we need to send some ether because it's payable, and the amount that goes into it can be withdrawn after again. So what we do is we also say value to send some ether, and we have this as the locked amount. This is here another parameter that we have set to 1 GWay, and we also make a from. So we want to say we want to call this initialize function from the proxy admin owner. And now you can see this interesting thing. We are actually calling to the proxy address, but we are calling the initialize function on the proxy address. So we have this transparent upgradable proxy deployed. We are calling it, but we are calling a function from the implementation directly. The proxy contract is transparent, meaning that it sees the initialize function and calls the implementation contract and evaluates this initialize function, but on behalf of the storage of the proxy itself. Perfect. So we have now called the initialize function. And the last thing that we would like to do is we would like to retrieve the address of the proxy admin. You might ask yourself now, where's the proxy admin? I mean, we haven't deployed the proxy admin yet. We have actually, because what we did is we deployed the transparent upgradable proxy, which means that we also directly deployed the proxy admin. And we can see that if we go to transparent upgradable proxy, or if you go inside the functionality here, let's find the constructor of the proxy itself. We can see that here we make a new proxy admin. So the constructor actually deploys a new proxy admin directly with the initial owner that we have set in the constructor parameter. So the proxy admin is already deployed by this call here. But what we need to do now is we need to get the address of this proxy admin because we need it later on to upgrade our contract. So let's say const proxy admin address. How do we retrieve it? We can read event arguments with read event argument. We want to read from the proxy, and this event is called admin changed and with the new admin name. So like that, we can retrieve the proxy admin address. And now we can just load the proxy admin itself with the address. So we say proxy admin is m.contract@. It's called proxy admin, the contract, and the address is the proxy admin address. So we are now loading this contract. And what we can return now, we can now return the proxy itself, and we can return the proxy admin. And using Hardhat Ignition, we can now use this module in another module. You can imagine it like Lego. You can execute this module, it gets a state, it deploys the contracts, and then after that we can use this module in another module where we can, for example, upgrade the contracts, or where we can load other contracts and so on. And then we kind of can build a state from the previous one. And we can build up our modules like that in a modular way. Perfect. Our Ignition module is ready. So let's for just test it. Let's try to run this script. We say npx hardhat ignition deploy, and we call this this module. So this is in ignition modules and then proxy ts, and we call that. Let's see what happens. It looks really good. If we go inside the logs, we can see we get a warning first. Of course, we are not executing it on any node, so we are just Hardhat is running a node by calling this statement, and then it will just quit the node after it's run through. So it's not really deploying anything, but that's not what we want. We just want to see if the script works by itself. So what it does is deploying the proxy module. Batch 1, it executed the log, so it deployed first the log contract. That's the first here. That's the implementation contract. Then it deployed the transparent upgradable proxy. That's this one. Then we go there. We have batch 3 log proxy instance. So it loads the log proxy, and we call the log proxy initialize function here. And yeah, that's here in the batch 4. We call the initialize function, and we also read the arguments from the new admin, from the proxy admin address, and we loaded this proxy admin, and we returned the proxy and the proxy admin. And we can see now some contracts were deployed. We have the log contract is on an address here. Then we have the transparent upgradable proxy on another address, and the log proxy instance. You can see this is the same address like the transparent upgradable proxy. Makes sense, right? We just loaded this address with the log contract, and we have the proxy admin on another address. So successfully deployed everything. Really nice. For now, we have created this module to set up all the contracts that we need for now for upgradable contracts. And now we will deploy that on a local node, and then afterwards creating a new version of our log contract such that we can upgrade our contracts. First, let's call npx hardhat node to set up a node. This will start on localhost here. On localhost with this port, it will start a new node, which we can use as a blockchain, a local blockchain, to deploy our things and test our stuff. So what we do, we open a new terminal. We just let the terminal running in the background, and we say npx hardhat ignition deploy, and we deploy this module. So we say ignition npx hardhat ignition deploy. I need first to go inside the project, of course. Upgradable contracts. Okay, and now npx hardhat ignition deploy and ignition modules proxy ts. and we deploy it. But of course I have forgotten something. Let's clear it again. I have forgotten to call the network. So we would like to use the local host network to deploy this script on our node that we have just started before. So let's call that, and that worked successfully. If we go back to our node, we can see there are some more logs now. These were all the transactions that we have sent throughout this Ignition script. And when we go to Ignition deployments, we have now a folder deployments on this chain, and we can see that we have some deployed addresses, and here we have all the addresses from our contracts. So what we can do again, let's just run the same command again here. Let's see what happens. And we can see nothing new to deploy based on previous execution stored in So what we can see, Hardhat is not doing anything because we have already deployed. So we already have the state of the blockchain is already correct with our module. We don't really deploy new things. We just have this state now. And now when we use this module, we will just get these addresses and we can continue working with those contracts. Really cool. So now let's say we would like to create a new version of our log contract. We found out that we need more functionality to this contract and we would like to upgrade this contract. So what we can do is we just create a new version of this log contract. We copy the implementation for now, and then we rename that to log version 2.sol. We also change here the name of the contract to log v2. We let everything as it is, but we can create a new function. So we say we would like to be able to change the owner. Right now this is not possible, but we would like to change this functionality. We would like to add this functionality. So let's say we create a new function called change owner with an address called new owner. We make this public. And we say the owner, the current owner is now the payable new owner. So we set the owner to a new address, which we can pass in the as a parameter. You can see this function can be called by anyone. So let's create a modifier that just the current owner can call this function. So modifier only owner, let's call it like that. And we require that the message sender is equal to the current owner. Otherwise we give an error. You are not allowed. And then we just execute the function itself. And this modifier we can use here. Only owner, such that only the owner can call that with a new owner and he can set this new owner. So really simple functionality, but we just added that to our implementation now. Perfect, our new contract is now ready. And now we can create a new Ignition module to upgrade our contract. So we go to modules and we create a new file, a new TypeScript file, and we call it upgrade.ts. And here we create a new upgrade module. So we say const upgrade module, and this is build module from Hardhat. So we are using this function. We need to import it, of course, first. So we say import build module, and this is from here, and then Hardhat Ignition and modules. So that's the build module function here, and we need to give first a name to this module. We call it upgrade module, And then we have a callback function with this parameter m, which we can use to deploy and do stuff with Hardhat. That's it. And we need to also export this module, default upgrade module. So what we do first, we load our proxy admin owner again, because we have said before that we have an owner or an admin which is allowed to upgrade our contract. So we need to load first the same user or the same address again. So we say const proxy admin owner m.get account, and we take again the first account which is provided by Hardhat. And then what we can do now is we say const proxy and proxy admin, and now it comes all the beauty of Hardhat Ignition. What we can do is we can say m.use module, and we just take the proxy module. So what we do is we say, okay, first execute everything here on this module if it's not executed yet, and retrieve all these addresses. So that's again the Lego thing, right? We have built already this proxy module, we have executed it, let's say 3 months ago we have executed that. Now we would like to upgrade it. We can just use this module to retrieve the current addresses, and now we can work from this state on. So what we can do is we can say, let's load our new v2 contract, m.contract log v2. Actually, that's not loading the contract, but that's deploying the new implementation. So we are deploying a new implementation first, and now we need to say to the proxy, take this new implementation as your true implementation. So what we can do is we can say m.call. So we make a normal call to a contract, and we make a call to our proxy admin, which we have retrieved from the other module. And we say we want to call the function upgrade and call. That's the function to upgrade our smart contract. What we need to say first is we need to first give the proxy itself. So the proxy admin, we call the proxy admin with this function, and we need to say, where is the proxy? The proxy is here. That's a transparent upgradable proxy. Plus, what is the address of the new implementation? Log v2. Plus, again, the call. So what we would like to execute, we would not like to execute anything. We'd just like to upgrade it. And then, as some more options, we say from the proxy admin owner. So we want to make this call from the proxy admin owner to the proxy admin, and we would like to execute the upgrade call. And we upgrade it to the log v2. And that's it. That's already the upgrade functionality. And we say return proxy admin. We give back the proxy admin. Maybe we will use it later on, and we also give back the proxy. Let's see. With that, we can now upgrade our contracts. So we can now, I will clear that here. We can now call npx Hardhat Ignition deploy, and we call the ignition modules and the upgrade ts. Of course, let's wait. I did a mistake again. I forgot the network again. Minus network. Local host to execute it on our local node. And we can see, let's go a little bit more into detail. So he's resuming the deployment. He has seen, okay, we have already a deployment, right? This proxy module is already deployed actually. And we can see we deploy a log2 in the first stage. And then we are calling the upgrade and call function on the proxy admin. And now we have again a summary of all the different contracts. These contracts, they just stay the same, of course. the lock contract, this is now just there. It's just on the blockchain, but it's not used anymore because it's not used by the proxy admin anymore. We have the transparent upgradable proxy, we have the proxy admin, and now we have the lock2 contract, which should now be used on the transparent upgradable proxy. You might ask yourself now, yeah, that's all good, but how can we show that this actually worked, the upgrade? We haven't tested absolutely anything yet. So now we can really use these Hardhat Ignition modules to write unit tests or to write integration tests. And that's exactly what we are doing now. And we want to check if the upgrades actually work and if we can now call the new function on our new implementation contract. For that, we need to write some more modules right now because we would like to use the ignition modules such that we retrieve the right contract there and we can write tests. So let's go to modules and create a new file, and we call it lock.ts. And I would just copy paste from another module everything. I just delete here the stuff and I call it lock module, lock module, and we export this module here. And now what we do is we say const proxy m.use module, proxy module, and we say const lock is m contract at the lock and the proxy address. So what we are doing here is exactly the same like before. Like we would like to get the proxy module, the deployed contracts from here. From the proxy module, we get the proxy, the transparent proxy, and we say the lock contract is actually the implementation at the proxy address, and we return that. So now we get just a lock contract through the proxy, and now we can start to test this contract. For that, we go to the test folder here and we open the lock.ts. We can see that here are many unit tests already. We just delete all of them. We don't need it for this tutorial. So let's delete them. And we create a new section called describe. And the section is called proxy interaction. So we would like to see if we can interact through the proxy with our implementation function. And here we can now write some tests. So let's say it should be interactable via proxy. So we want to test if we can call the implementation through the proxy async function. And what we can do now is we can just say const lock is equal to await ignition dot deploy, and we can get the lock module. So if we go to see, that's just one line of code that we need, but what it does is it goes through this lock module, it uses the proxy module, it deploys all the proxy contracts that we need and the implementation as well, and then it returns us the lock contract, which is the proxy address and the lock implementation. So yeah, we just have now this lock, the proxy contract with the lock implementation, and now we can check if this is actually working. So let's say expect, we call the lock dot unlock time. I think that's one public variable on the lock contract. Yeah, exactly. Public uint public unlock time. So we can retrieve the unlock time, and we say this to equal, and I just say 0 for now. That's not correct, but I would like the test to fail to see what we get there. So we say now npix hardhat test, and let's see if that runs. Really nice. It ran through. It failed the test, of course, because the unlock time is not set to 0. It is set to this number here. And when we go to see in our deployment script or in our ignition script in the proxy section, we have set the unlock time to this value, and this is then transferred to the initialize function, and which comes now from the proxy itself. Really good. So let's add this number here, or better, let's add this number here and see if the test now passes. Perfect. What we can try more is we can see if it should already be initialized. So is the initialize function already called? We can again say, get me the lock contract, and expect that if I call the lock contract initialize with a value to be reverted. So this should give me an error. Let's see. And that works also fine. Perfect. So now the last step that we would like to do is we would like to see if the upgrade works actually. So we can say it should upgrade. And for now, we would like to do this one here, but we would like also to call the upgrade script, right? So what we do is we create a new module here, and we call it lock v2.ts. And what it does kind of the same like the lock v1. However, we call it lock v2 module, lock v2 module, and we say we want to not use the proxy module. We would like to use the upgrade module now. So we would like to upgrade our contract before, and then we want to return the lock contract, but now the lock v2 contract through the proxy. And we export this module, everything good. And now we can use this lock v2 module in our test. So we can say const, again the lock, and we say we want to await ignition dot deploy, and we want the lock v2 module to be deployed. What we need also is some other accounts. So we need some other signers that we can exchange the owner, because we have seen that in the v2 implementation we have now a new function which is able to change the owner. So we say const, and we have the current owner. This is the first account, and we have another account that we would like to load through Hardhat. So ethers get signers, like that. Perfect. So we are now loading these two accounts. So the first one should be the current owner. This is the one, the first account that we have used to deploy the proxy admin, and we also set it as an owner as we called the initialize function. So we can say now what we expect is we expect the current owner of the lock contract to equal the current owner address, right? So right now we can just call the owner. That's nothing special. This we could have called already before. We could already have written a test about that. We just see it here, and we can see that this passes. That means the current owner is correct. But now we would like to execute the new function that we have added in the v2 contract. So the change owner function with a new owner that we would like to have, and we would like to have the other account address, and we execute that by default with the current owner, so that should work. And when we do that, we expect that the log owner now to equal, I would say now current owner address. That should be wrong, right? Now we should get an error just to see if that worked fine. And we can see, yes, that's an exception. So the owner is now not the current owner anymore. So what is the owner? It should be the other account. Let's put the other account here and let's execute that. And we can see that all our tests have run. Of course, we could write many more tests now, but I think for this tutorial we have seen how everything works under the hood. And it's really beautiful that we can see how this Hardhat Ignition can be used for upgradable contracts, and we can deploy them in a modular way, and we can build up our modules by ourselves. If you made it up to now, congratulations, you have learned a lot about upgradable smart contracts and Hardhat Ignition. If you liked this video, please smash the subscribe button and like this video. This will help us a lot to provide you more content about Solidity smart contract development. So thank you and have a nice day.